Swayam Prabha. Digital India. Educated India.
Welcome back, learners. The video is for the subject of Geography for the course of Bachelor's in Arts with Geography or Bachelor's in Arts with Honours in Geography. The video is for the paper of Climatology. Today we are going to start Lecture 8 of Module 3. The topic of the lecture is El Nino, Southern Oscillations and Walker Circulation. This particular video lecture is part 1 of Lecture 8. Because the topic is long, therefore the video lecture is divided into two parts. And this particular video lecture is part 1 of video lecture 8. The video is being recorded by Dr. Pallavi Upreti. The course coordinator and presenter for the video is Dr. Pallavi Upreti, affiliated to Department of Geography, Doon University. The academic expert and reviewer for the video is Professor Santosh Verma, Head of the Department, Department of Geography, SDM PG, Government Degree College, Doiwala, Dehradun, affiliated to Shri Dev Suman, Uttarakhand University. The video is produced and presented under the project name DTH Swayamprabha Channels of MHRD, New Delhi, India. Hello learners, I am Dr. Pallavi Upreti, Assistant Professor in the Department of Geography in Dr. Nityanand Himalayan Research and Study Center, Doon University, Dehradun. This particular video lecture is the 8th lecture of Module 3, wherein we will be discussing in detail the El Nino, Southern Oscillations and Walker Cell. As we are aware and we have already done in the previous video lectures, the general atmospheric circulation, which is commonly north-south. But besides the north-south atmospheric circulation, we also have additional east-west atmospheric circulation also. So in this particular video lecture, we will be studying what is this east-west atmospheric circulation, what is the mechanism for the east-west atmospheric circulation, what are the different concepts related to it, and what are the various theories which are being given to explain this particular atmospheric circulation mechanism. So let's begin. In the due course of this video lecture, the learners will be able to understand in general the phenomena of El Nino Southern Oscillation or ENSO, and the learners will also be able to understand the different phases of the ENSO cycle and how the different phases of ENSO cycle affect the weather conditions in specific latitudes. And finally, we will be understanding the impact of ENSO or El Nino Southern Oscillations on monsoons in India. So let's begin. In addition to the existing north-south atmospheric circulation pattern, which we have discussed earlier in form of Hadley cell, Ferrel cell, and polar cell, which are essentially part of a larger tricellular meridional circulation system. So in addition to these north-south circulation patterns which exist on our Earth, there are other weaker east-west circulation patterns also that can significantly affect weather. And one such pattern or one such phenomena is ENSO, which stands for El Nino Southern Oscillation Phenomena. The ENSO phenomena is primarily experienced in the tropical areas of the world, and these circulations are consistent primarily along the warmer equatorial zones. Why warmer equatorial zones? Because as we know that the tropical areas receive abundant sunshine throughout the year, due to which the air constantly expands, uplifts, condenses after reaching heights in the atmosphere. So basically the air is constantly in motion, leading to very dynamic atmospheric conditions and dynamic temperature conditions also in these areas. So these dynamic temperature and atmospheric pressure conditions lead to unique atmospheric conditions giving rise to El Nino Southern Oscillation phenomena. And these areas, as we know, that they are also dominated by the trade winds, and trade winds mostly blow from east to west in the tropical areas of the world. Therefore, the circulation pattern which exists in these areas, which are comparatively weaker than the other north-south circulation patterns, is mostly in east-west direction. So ENSO is the weak east-west circulation pattern which is predominantly observed along the tropical areas of the world. The term ENSO stands for El Nino Southern Oscillation, and as the name suggests that something is oscillating back and forth. And in this particular case, the term oscillation is actually used to denote the changes in the temperature conditions specifically over the ocean surfaces. So it is the ocean temperature that is oscillating back and forth from warm to cold and vice versa. Therefore, ENSO circulations are primarily associated with the oscillating temperature conditions driven by large-scale changes in the sea level pressure, which are specifically observed over the tropical areas of the world in the southern hemisphere, primarily due to immense insolation, heating, cooling in the tropical areas of the world. Hence, the term southern oscillation is used. And where these changes are actually observed? In the global ocean waters of the world, which cover millions of square kilometers latitudinally and longitudinally. So here we are talking about the Pacific Ocean. This phenomena is primarily observed over the Pacific Ocean with massive north-south and east-west extent, almost covering more than one-third area of the globe. And this large pool of water exists between Asian and Australian continent towards its west to the North American and South American continent toward its east. So it has a massive north, south as well as east-west extent covering more than 155 million square kilometer of the area globally. And the Pacific Ocean also makes contacts with the other oceans of the world. For example, it is connected through Bering Strait to Arctic Ocean, and it also makes contacts with the Southern Oceans near Antarctica. Similarly, it is also connected to Indian Ocean, somewhere around Australia, as you can see here, and it also makes contact with the Atlantic Ocean, also around Drake's Passage, which is located south of South America. So this large pool of water gets warmed up around the equator, which leads to fluctuations in the east-west sea surface temperature across western, central, and eastern tropical Pacific Ocean. So because it has immense north, south, and east-west extent, when this large pool of water body gets heated up specifically around the equator, it can actually impact the weather conditions around the globe. So warmer or colder than average temperatures in one part of the Pacific Ocean can have significant impact on weather and climatic conditions across the globe because of its massive extent and aerial coverage, almost connecting to all the major regions of the world. The oscillating temperature conditions from warm to cool and then again from cool to warm leads to unique conditions in the Pacific Ocean, which is characterized by periodic warming as well as periodic cooling of the Pacific Ocean, specifically around the tropical areas near the equatorial regions of the southern hemisphere. So due to massive east-west extent of the Pacific Ocean, there are differences in the pressure and temperature conditions which exist in the eastern region of the Pacific Ocean as well as in the western region of the Pacific Ocean. And these seesaw variations in the temperature conditions of the Pacific Ocean was first observed by Sir Gilbert Walker in the earlier 20th century when he was trying to understand the conditions of failure of Indian monsoon and prevalence of drought in the Indian subcontinent. So he observed seesaw variations between the Indian Ocean as well as the Eastern and Western Pacific Ocean, and these variations were much more pronounced in the Southern Hemisphere. Therefore, he gave the term Southern Oscillations, primarily to describe the large-scale seesaw fluctuations in the pressure and temperature conditions followed by fluctuations in the precipitation conditions in the southern Pacific Ocean. So later on, several global climatic variations and climatic conditions were also linked with this southern oscillation phenomena, the concept which was given by Sir Gilbert Walker. So later on the episodes of warming of central and eastern Pacific Ocean, the phenomena which is known as El Nino phenomena, which was observed somewhere around the South America in the tropical Pacific Ocean waters, was also linked to the concept of this southern oscillation, and together the entire phenomena was later on known as the ENSO phenomena or the El Nino southern oscillation phenomena, and which today we know that it is cyclic in nature. So the entire phenomena is cyclic in nature with phases of periodic warming as well as cooling patterns which are observed over the Pacific Ocean, specifically in the southern hemisphere. So the initial concept of southern oscillation, which was given by Sir Gilbert, which today has evolved to describe a climate change phenomena with observed influence on several global scale ocean atmospheric processes. So today this El Nino southern oscillation concept or the ENSO concept or the ENSO cycle has evolved as a climate change phenomena which exert observed influence on several existing ocean atmospheric systems, processes, and phenomena. The ENSO circulation or the El Nino southern oscillation is actually a recurring climatic pattern or phenomena which involves changes in the temperature of waters in the central as well as eastern tropical Pacific Ocean. So as we know that these areas are also influenced by the movement of trade winds at ground surface, which primarily move from east to west under the Coriolis force in these tropical regions of the world. So although the movement and circulation of trade wind is part of larger tricellular meridional circulation model and Hadley cell circulation, which is mostly in north-south direction, but at the ground surface the movement of trade winds from east to west near the ground surface give rise to conditions which lead to the weaker east-west circulation near the Earth's surface as ENSO phenomena. These zonal circulation cells exist primarily because of the large east-west gradient in the sea surface temperature, which is primarily observed in the Pacific Ocean, as well as due to the heating and cooling of the tropical continental regions around the Pacific Ocean, which create unique conditions for the ENSO phenomena to occur in certain time periods of the year. And due to all these unique conditions, the ENSO phenomena exhibit pattern of low atmospheric circulation, which is influenced greatly by the east-west movement of the trade winds in the tropical region over the Pacific Ocean. So ENSO phenomena is not just the ocean phenomena, but it can be seen as ocean atmospheric interaction where you have a ocean component due to fluctuations in the sea surface temperature, and these fluctuations in the sea surface temperature along the western and the eastern coast greatly influence the atmospheric conditions of the area also. So it has a ocean component as well as it has the atmospheric component also, and it can be seen as ocean atmospheric interaction process. And due to the ocean atmospheric interaction, the changes in the sea surface temperature along both the coast of Pacific Ocean affects the rainfall distribution in the tropical areas and can have a strong influence on the weather across Asia, America, and other parts of the world along both the coast of Pacific Ocean due to its massive aerial coverage. The ENSO phenomena is cyclic in nature, which means that it has got different phases which are experienced in different time periods in the Pacific Ocean. So it has got a neutral phase, which is characterized by usual warm conditions in the Western Pacific Ocean and cooler conditions in the Eastern Pacific Ocean. The second phase is the El Nino phase, which is also called as the warm phase of the Pacific Ocean, and it is characterized by warmer than usual temperatures which exist in the central as well as the eastern Pacific Ocean. And the third phase, which is opposite to El Nino, is the La Nina phase, which is the cooler phase of the Pacific Ocean, and this is characterized by cooler than usual temperature in the central and the eastern Pacific Ocean. So there are certain time periods where the Pacific Ocean becomes warmer, that is in the El Nino phase, and there are certain time periods when the Pacific Ocean becomes cooler than usual, that is during the La Nina phase. And both the phases are separated by intermediate neutral phase in between, which is marked by the usual conditions which prevail in the Pacific Ocean. So let's now understand all the different phases of the ENSO cycle one by one in detail. Now let's first understand the conditions which exist in Pacific Ocean during the neutral phase of ENSO cycle. Central Pacific Ocean along the equator is warmed up due to constant heating whole year round, as we know that this particular area near the equator receives direct insolation throughout the year, because of which the sea surface temperature of the Central Pacific Ocean remains higher whole year round. Besides this, this particular area is also dominated by trade winds, which move particularly from east to west in this tropical zone, and these trade winds pushes and drags the warm surface water towards Asia, primarily because they move from east to west. So these trade winds piles up the warm water along the Asian coast, and this entire area becomes warmer as compared to the eastern side of Pacific Ocean. Therefore, the western side or the Asian side becomes warmer. The sea surface temperature become warmer as compared to the eastern side or the South American coast side of the Pacific Ocean. So this piling up of water along the western side is also called as Western Pacific Pool, and this is a warm water pool which accumulates along the western side of Pacific Ocean due to the constant pushing of trade winds. So when the trade winds pushes the warm surface water towards the Asian side or the western side, the warm water accumulates along the western coast of Pacific Ocean. And inside the sea, the piling up of this warm water along the western side pushes the cold water towards the bottom, which moves towards the eastern side, resembling as a giant conveyor belt type movement, and the cold water from the bottom of the Pacific Ocean piles up towards the eastern side, and it is pushed towards the surface, which is called as upwelling. So when the cool water from the bottom of the Pacific Ocean is pushed towards the surface of the Pacific Ocean, it is called as upwelling of water, because of which the eastern sea surface of the Pacific Ocean becomes cooler as compared to the western side of the Pacific Ocean, which is comparatively warmer. So these conditions exist normally in Pacific Ocean, and this systematic equatorial circulation associated with the zonal pressure gradient was named as Walker cell by B. Jerkins. So B. Jerkins was studying the fluctuations in the Pacific Ocean, and he named this particular kind of fluctuations or zonal pressure gradients which exist in the central Pacific Ocean along the equator as the Walker cell. So the neutral phase of the ENSO cycle is also called as Walker cell, and any deviation from Walker cell may either lead to warming up of Pacific Ocean or the cooling up of Pacific Ocean. So in neutral phase, the western side of the Pacific Ocean is comparatively warmer than the eastern side of the Pacific Ocean, which is comparatively cooler in nature. So all this happens along the equatorial belt, specifically located along the southern and central Pacific region. Under the ocean, what is happening? The constant piling up of water along the western coast is actually pushing the cool waters below, and these cool waters are pushed towards the eastern side or the Peruvian side, where they reappear and are pushed toward the surface, leading to upwelling. So what is happening above the surface of Earth? How this piling and accumulating of water along the western Pacific Ocean is actually affecting the weather conditions in these areas. The warm ocean current affect the weather condition by increasing the temperature and moisture content along the western coast. So because of a lot of piling up of warm water in this area, the temperature also increases, and consequently the warm air being light rises up in the atmosphere, leading to condensation and rainfall in these areas. The warm air then, after reaching a particular height in the troposphere, diverges in opposite directions. So one wing goes towards the west and the other wing move back towards the Peruvian coast, and it reaches back near the eastern Pacific coast, where it sinks down. The sinking of this air from above also leads to comparatively high pressure conditions in these areas. And again, the trade winds which are moving above the sea surface drags the warm sea surface ocean waters towards the western side. So this pattern of rising of air in the west and sinking in the east continues, and it is called as Walker cell. So the neutral conditions are actually called as Walker cell, the name which was given by B. Jerkins after trying to understand the pressure differences which exist in the tropical equatorial Pacific Ocean. As warm near surface ocean water is pushed from east to west, the deeper cooler water along the eastern Pacific coast rises to the surface and fill the gap, which is called as upwelling. So along the Peruvian coast, you have the upwelling of cooler water from below. As you can see in this particular diagram here, that the cooler water is constantly being pushed from the deeper ocean bottoms towards the ocean surface, decreasing the temperature along the eastern side of the Pacific Ocean. Once the cooler water reaches the surface, it is again dragged by the trade winds, and they become part of this entire conveyor mechanism which is happening in this particular area. And again, all this water is again piled up along the western coast near Asia and Australia, completing the circulation. So you can say that ENSO phenomena is not only related to the movement of warm and cold waters within the ocean, but it is also very much associated with the atmospheric circulation, and it affects the atmospheric conditions in these areas. So it is both. It is oceanic phenomena also, and it is atmospheric phenomena also. So these are the neutral conditions, and these neutral conditions are called as the Walker cell also. Now let's see how these neutral conditions in different phases, in El Nino phase and La Nina phase, deviates from the neutral conditions and become different. So let's see how under the El Nino and La Nina phase these neutral conditions are modified. Here in this particular diagram, you can clearly see that how the western side of the Pacific Ocean have comparatively warmer sea surface temperature as compared to the eastern side of the Pacific Ocean or along the Peruvian coast of South America. So along the Asian, Australian coast, you have warm waters, okay, and along the eastern Pacific coast you have cool waters, primarily due to the upwelling of water from below, as the piled up water along the western coast pushes the warm waters down towards the bottom along the western side, which pushes the cool water from below to accumulate along the eastern side and rise up towards the sea surface. which is called as upwelling. So this upwelling is generally experienced along the southern eastern Pacific coast, okay, or along the western coast of South America, along Ecuador, Peru, in these particular areas. And what is happening above the ocean surface? Due to constant piling up of water, the temperature of this particular area increases above the Pacific, due to which the air warms up and it is uplifted and leads to condensation, causing precipitation along the Asian side. And after reaching a particular height in the troposphere, it diverges in opposite direction. One wing reaches back towards the eastern Pacific Ocean side and it sinks towards the Earth's surface, again leading to high pressure conditions. And as soon as these particular winds reaches the Earth's surface, they are again dragged towards their western side due to the movement of trade winds, which move from east towards west very close to the Earth's surface. So in that process, they kind of drags the warm surface water with them and accumulates along the western side of Pacific Ocean, which is also called as Western Pacific Pool.
Now let's see what happens during the El Nino phase of ENSO cycle. El Nino represents the warmer phase of the ENSO and it is associated with the band of warm ocean water that develops in the central and the east central equatorial Pacific region along the Pacific coast of South America. In some years, you have to understand that the strong trade winds, which usually blow from east to west, are ill developed or are weak, especially along the equator. So, during the time periods when the trade winds are weak, this creates high pressure conditions in the Western Pacific Ocean and low air pressure conditions in the Eastern Pacific Ocean. So the initial conditions which were existing during the neutral phase, where you had piling of water along the Western Pacific coast and existing warm conditions along the Western Pacific coast or Asian Pacific coast are reversed during the El Nino phase. So because of poorly developed trade winds, the piled up water along the western side starts moving back towards its original position. And in that phase, what happens as it moves back to its original position, the central and the eastern Pacific Ocean temperatures also increases. So now we have high temperatures along the eastern Pacific Ocean also, and there is a band of warm ocean water which moves from the west towards east, making the entire central as well as the eastern Pacific Ocean warmer. So these changes in air pressure and wind speed causes warm surface water to move eastward, okay, eastward from the western Pacific coast, that is from the Asian side, towards the South American coast. So because of all these conditions, there is no upwelling of water which was initially happening during the neutral phase. So the upwelling of water stops. This unusual warming of Pacific Ocean along the coast of Peru specifically in the South America was first experienced in 1600s by the fishermen, and they called this El Nino phenomena as the little boy phenomena or the Christ child phenomena, since this particular phenomena peaked during the Christmas time period in certain years. However, the term El Nino was coined by B. Jerkins when in 1960s he was trying to understand the anomalous drought conditions in India, and he linked the El Nino conditions or this unusual warming of central and eastern Pacific Ocean conditions with the existing southern oscillations given by Gilbert Walker. So the systematic fluctuations in the temperature and pressure conditions or the seesaw type of fluctuations in the temperature and pressure conditions along the eastern and western Pacific Ocean were given the term as southern oscillations. But Gilbert, after extensive research also was not able to associate the oscillating pressure conditions with the El Nino or unusual warming up of eastern and central Pacific Ocean. And this link was established by B. Jerkins, and he provided an explanation for the association of the low phase of the southern oscillation with El Nino, as well as the association of the high phase of southern oscillations with the normal cold state of eastern Pacific Ocean, also called as La Nina, which we will study in the coming slides. So for now, you have to understand that El Nino is the unusual warming up of the central and eastern Pacific Ocean. So during the El Nino phase, because of poorly developed trade winds, abnormally strong winds originate from the west, pushes the mass of warm surface water from the equatorial regions of the Asian side towards the equatorial South American side, and are ultimately deflected towards Mexico, Peru, and Ecuador region, creating an area of warm surface water for thousands of kilometers in length in the central and eastern Pacific Ocean. So these surface water deepens the thermocline that can dip as far as 150 meters also, which create a very thick layer of warm water over the Pacific. And this thick layer of warm water does not allow the normal upwelling to occur, as it was usually occurring along the South American coast. So the upwelling of the cooler water along the eastern Pacific coastline slows down or stops entirely, leading to warming up of eastern and central Pacific surface waters. So there is a band of warm water which initially had piled up along the western side, and now this piled up water kind of moved back due to poorly developed trade winds to its original position, creating a band of warm water in the central as well as the eastern Pacific Ocean. So any fluctuations from the neutral conditions, either it can be the warming up of sea surface temperatures of Pacific Ocean or cooling of the sea surface temperatures of Pacific Ocean, can create extreme weather conditions in different parts of the world, especially in the tropical areas along both the coast of Pacific Ocean, along the Asian coast as well as the American coast. The east-west pressure gradient, which is associated with the Walker cell or the neutral conditions, undergoes interannual variations. That is, these areas experience periodic warming as well as periodic cooling of the surface water due to oscillations in the temperature and pressure conditions. So originally you can say that the term El Nino was applied to reflect the weak warm ocean current that ran south along the coast of Peru during the time of Christmas. Initially it was seen as a very localized phenomena. However, over the time, the term El Nino has evolved to describe the climate change phenomena, and now it refers to the warm negative phase of the El Nino southern oscillation cycle and warming up of ocean surface water above average existing sea surface temperatures in central and eastern Pacific Ocean, led by Sir Gilbert in 1930s, who gave the term southern oscillation, and then later on the term El Nino given by B. Jerkins. The concept of El Nino has become global in nature, impacting the temperature, the rainfall, the precipitation regime in the tropical areas. Now let's just quickly see how the neutral phase conditions fluctuate, leading to El Nino phase. So as we have studied in the earlier slides, during the neutral phase, due to well-developed trade winds, there is constant piling up of warm water along the Asian coast or along the western Pacific coast. And this piling up of warm water increases the air temperature also, which becomes lighter, moves up in the atmosphere, condenses, leading to precipitation. So during the neutral phase, you have normal precipitation conditions along the Asian coast. And after reaching a particular height in the atmosphere, the air cools down and it sinks along the eastern Pacific coast And what happens in the ocean? Because of the immense piling up of water at one side, it pushes down the cold water, which is pushed towards the eastern side and appears on surface, reducing the temperature of the eastern Pacific Ocean. So usually you have cooler conditions along the eastern Pacific coast and warmer conditions along the western Pacific coast. But what happens during the El Nino phase of ENSO cycle? During the El Nino phase, due to poorly developed trade winds, this east-west dragging of warm water stops, and the already piled up water along the western coast starts moving back to its original position, and in the process it creates band of warm surface water in the central as well as the eastern Pacific Ocean, which usually under neutral conditions are cooler areas. So now these areas experience warmer than usual sea surface temperatures. So now the Asian side in El Nino phase do not experience normal precipitation. Rather, the precipitation also shifts to central Pacific Ocean where you have piling up of warm water, and the central Pacific and the central eastern Pacific region experiences rainfall. And again, after reaching a particular height, when the air cools down, it diverges in opposite directions. So the Asian side now experience the sinking of air from above, creating high pressure conditions and low rainfall conditions. So besides atmospheric conditions, what is happening in the sea? Now as the warm band of water swirls back towards the central part, there is a thick layer of warm water, okay, which covers the top layers of Pacific Ocean. So the upwelling of cool waters from below, as it was experienced during the neutral phase, is also retarded. So there is no upwelling of cool waters from below also along the eastern Pacific coast. The ENSO El Nino conditions are associated with the warmer central and eastern surface water conditions in the Pacific Ocean along equatorial areas. So the coast of Peru, Ecuador, all these areas experiences warmer than usual temperature of ocean waters in the coastal areas. And this phenomena in Peru is also called as the Christ child or the little boy phenomena. So the temperature and pressure over the Pacific oscillates while diminishing the intensity of trade winds during certain years, leading to eastward movement of the waters along the equator, creating warm surface temperatures along the central as well as the eastern Pacific Ocean. So in this phase of oscillation, the pool of warm water in the Pacific near South America is often at its warmest during the December time period, and warmer than usual increase in temperature is experienced specifically along the coast of Peru, where this unusual warming of Pacific waters is called as the Christ child phenomena. Now, typically, the El Nino conditions happens at irregular intervals of 2 to 7 years and last for 9 months to 2 years. However, over the few decades, the ENSO saw several events of warming of the central and eastern Pacific Ocean, the intensity and the extent of which has increased specifically after 1980s. So periodic events in 1986, 1990, 1991, 94, 2000, 2004 and thereafter were experienced where the Pacific Ocean water became unusually warmer under the El Nino conditions. However, they typically last for 9 to 2 years, but sometimes the El Nino events may also last for 4 to 5 years. So when this warming occurs for 7 to 9 months, it is classified as El Nino conditions. But when the duration is prolonged and it becomes predominant in those conditions, it is called as the El Nino episode. And during the El Nino episode, the central and the eastern Pacific Ocean receive more rainfall than usual, whereas the western Pacific Ocean side does not receive that much rainfall, and drier conditions than usual prevail along the Asian coast or the West Pacific Ocean region. Now, generally, any fluctuations in the Walker cell or any deviations from the normal conditions causes widespread and sometimes severe changes in the climatic conditions, and it may also affect weather of many areas differently, specifically along both the coasts of Pacific Ocean. As the El Nino denotes the warmer phase of the central and eastern Pacific Ocean, the tropical areas specifically along both the coast of the Pacific Ocean may experience different kinds of weather conditions. The warm waters along the eastern coast specifically causes the Pacific jet stream to move south of its neutral position. With this shift, the areas in the northern US and Canada are drier and warmer than usual. So, existing warmer conditions in the central and eastern Pacific Ocean along the tropical belt, the Pacific jet stream shifts southwards than its usual position, and this leads to drier condition in certain North American states as well as certain regions of Canada also. So drier than usual or warmer than usual conditions prevail in these areas, while the southern parts of USA experience wetter than usual conditions where the jet stream establishes itself. So you have wetter conditions than usual in the southern USA, while you have warmer and drier conditions in the northern parts of USA and certain parts of Canada also. Besides this, convection above the warmer surface water brings increased precipitation along the eastern region. So because of unusual warming of eastern and central Pacific Ocean, the central as well as the eastern Pacific Ocean experiences higher than usual rainfall. Specifically, rainfall increases drastically along the coast of Ecuador, northern Peru, the US Gulf Coast, and certain southeastern regions of Central America, contributing to coastal floods and extensive erosion in certain parts of these areas. So the entire eastern coast of South America along Ecuador, Peru, Chile, and the eastern coast of Mexico and certain Central American regions, southern USA, they all experience very high torrential rainfall during this time period when their El Nino conditions prevail. And while these eastern regions are experiencing heavy precipitation, flooding, erosion, it brings drier conditions to the western part of Pacific. Along the Asian side, you have less precipitation. Drought conditions prevail along the western regions of Pacific, along the Indonesia, Australia, South Asian and Southeast Asian region. So the Asian side, which usually receives good rainfall, experiences drought and drier conditions when the El Nino conditions prevail in the central and eastern Pacific Ocean. And during this time period, because of the El Nino effect, the monsoons in India are also ill developed. And India and Southeast Asian region also receives very less precipitation because of this ill-developed monsoon during the El Nino phase. Now, the El Nino phase influences the weather conditions along both the coasts of the Pacific Ocean, and the stronger El Nino events may disrupt the global atmospheric circulation, while the strong temperature increase causes severe climatic changes, with the Asian and Australian side experiencing harsh drought conditions with diminished rainfall. The eastern side, because of unusual warming, experiences record high rainfall, flooding along the whole coastal belt in North and South American region. In the tropical area, El Nino has devastating impact on Ecuadorian and Peruvian economies also, because usually these areas experience upwelling of cold waters from below, and upwelling brings nutrients rich cold water which attract the fishes and support the fishing industry. So the euphotic zone of the eastern Pacific Ocean, because of this unusual warming during the El Nino phase, can no longer support its normal productive coastal ecosystem, because now the upwelling completely stops and the nutrients rich water does not upwell to this coast, leading to low productivity of fishing industry on which the Ecuadorian and Peruvian economies are heavily dependent. The western coast of North America is stormy during the winter season. So same happens along the North American coast also, which is usually stormy in the winter season, and fish catch dramatically reduces from Chile to USA because of the reduced upwelling and existing warm sea surface conditions which are not conducive for fishing. The fishing industry experiences setback right from Chile to North America. So this entire tropical coastal belt along the eastern Pacific Ocean experiences poor fish catch. Besides this, strong El Nino events also contribute to weaker monsoons in India and Southeast Asia region. So as B. Jerkins has already established a relationship between the oscillations in the Pacific Ocean to the fluctuations in the monsoon. So when you have El Nino conditions and you have drier conditions along the western Pacific Ocean, during that time period, the monsoons are also ill developed in the Indian subcontinent and Southeast Asian region, with diminished precipitation which heavily impact the economy of these areas also, specifically in the Indian subcontinent, because the region is primarily dependent upon the monsoon rains to support its agriculture and agriculture allied sector. ENSO has even contributed to increased rainfall during the rainy season in the sub-Saharan Africa during the northern summers. So you can see the prolonged impact of the El Nino conditions over as far as Africa also. So during the northern summers, this particular area also experience increase in rainfall, which usually is very less during the normal neutral conditions. So you can see that any fluctuations from the normal conditions, whether it is warming or cooling of the Pacific Ocean, and in this case it is the warming of Central and Eastern Pacific Ocean, can have prolonged impact across both the coast of Pacific Ocean. While the western side of Pacific Ocean may become drier with prolonged drought conditions, the eastern side of Pacific Ocean may experience heavy rainfall with flood conditions in many regions of North America and South America. So the impact of El Nino events can disrupt the global atmospheric circulation along both the adjoining coast of Pacific Oceans and sometimes beyond also.
While the El Nino term initially was used to describe a very localized kind of warming event along the coast of Peru and along the western South American coast or eastern Pacific Ocean coast, but over the time period, it has evolved to describe a climate change phenomena with predominant impact on global atmospheric circulation, wherein now it is referred to as the warm and negative phase of a larger ocean atmospheric phenomena, which is called as ENSO or El Nino Southern Oscillation. So bringing all the concept of Southern Oscillation, which was given by Gilbert, and the concept of El Nino, which was described by B. Jerkins, today climatologists determine that the El Nino events are closely associated with the Southern Oscillation phenomena, and therefore the El Nino Southern Oscillation or the ENSO cycle exists with a warmer phase as one counterpart and a cooler phase as another counterpart, with variable impacts on global atmospheric circulation, weather patterns, temperature and precipitation regimes along both the coast of Pacific Ocean and beyond. So in this particular video lecture, we have had a fair understanding of what El Nino Southern Oscillation phenomena is, and we have discussed the two phases out of the three phases of the ENSO cycle in this particular video, which is the neutral phase and the El Nino phase of the ENSO cycle, and the remaining phase, which is the La Nina phase, and several associated concepts with it will be discussed in next video, which is M3 Elite Part 2. Thank you for now.